Somewhere in a factory outside Shanghai right now, a machine is folding laundry, walking upstairs, and picking up a glass of water without spilling a drop. It is not a science experiment. It is not a stage demo running on a hidden human operator. It is a product. It has a price tag. And it shipped in the thousands last year. Now here's the part that should genuinely alarm anyone watching the so-called robot race from the West. While Silicon Valley spent the last year building hype decks, teasing reveal events, and promising a robotic future that was always 12 months away, another country was quietly doing something far more dangerous. It was shipping. Actually shipping. By the truckload. And the numbers, once you see them side by side, are almost embarrassing. China now controls roughly 90% of the entire global humanoid robot market. Not 90% of headlines. Not 90% of investor hype. 90% of actual robots sold, built and delivered into real hands, real warehouses, real factories. Meanwhile, the company most people assume is leading this industry, Tesla, Elon Musk's trillion-dollar bet on a humanoid future, sold a number so small it barely registers next to China's output. So let's ask the uncomfortable question up front. If Tesla is supposedly building the robot that will change civilization, why is a completely different country already mass-producing them at a scale Tesla hasn't come close to touching? Stick with me, because the answer is not simple, and it is not what most people assume. Let's start with the raw numbers, because numbers don't lie, even when marketing does. In 2025, Chinese manufacturers shipped more than 14,500 humanoid robots. 14,500 units out into the real world. During that same year, Tesla, along with other major American players like Figure AI and Agility Robotics, each delivered somewhere around 150 units. 150, not 1,000, 150. Read that gap again. 14,500 versus 150. That is not a close race. That is not China is a little bit ahead. That is a different universe of production. Some analysts have called it exactly what it looks like. Not a gap, but a chasm. And the uncomfortable truth buried inside that chasm is this. The humanoid robot race may already be decided in terms of who controls manufacturing scale, even while the world is still arguing about who has the smartest robot. Two Chinese companies did almost all of the heavy lifting here. Unitree and a company called Agibot together shipped more than 10,000 robots between them, more units, combined, than Tesla's entire production target for the whole year. And Tesla, notably, did not even hit that target. The company aimed for 5,000 Optimus robots in 2025. It fell short. Meanwhile, Unitree alone outsold that target with a single humanoid model priced at under $6,000. Agibot sold over 5,000 units of its own, with a base model priced around $14,500. Let those prices sink in for a second, because pricing is where this story gets even more interesting. Advanced humanoid robots, historically, have cost anywhere from $150,000 to $500,000 per unit. That's the kind of price tag that keeps humanoid robots locked inside research labs and demo stages, not on factory floors doing real work. But Chinese manufacturers are shattering that price ceiling. We are talking about functional bipedal robots selling for the price of a used car. That is not a small technical achievement. That is a complete rewriting of the economics of an entire industry. And here's where the story stops being just about robots and starts being about something much bigger, a pattern. Because if this sounds familiar, it should. It is almost a carbon copy of what happened with electric vehicles. A decade ago, the world assumed America would dominate EVs because, well, Tesla invented the modern EV playbook. Tesla built the batteries, the software, the charging network, the whole vertically integrated machine. And for a while, that assumption held. But China didn't try to out-innovate Tesla in the same lane. China went a different direction entirely, building an entire domestic supply chain, subsidizing production at a national level, and scaling manufacturing to a size no Western company could match. Within a few years, Chinese EV makers like BYD were not just competing with Tesla. They were outproducing it, outpricing it, and expanding into markets across the globe faster than Western regulators could even react. Now, watch what's happening in humanoid robotics. It's the exact same playbook, running a second time in a completely different industry. China's push into humanoid robotics didn't start last year, and it didn't start by accident. It goes back to 2021, when the humanoid robot sector was explicitly named as one of the key strategic technologies inside China's 14th five-year economic plan. That's not a casual industry trend. That's a government, at the highest level, deciding years in advance that robotics would be a pillar of national strategy, and then backing that decision with real money. State funding has poured into testing infrastructure. Local governments have handed out subsidies. Individual robotics companies have received direct backing from public and private capital working hand in hand. One industry analyst summed up China's advantage as a combination of policy support, massive public investment, an already mature manufacturing supply chain, and rapid advances in both the AI software and the physical hardware needed to build these machines. In other words, it's not one secret ingredient. It's 4 or 5 advantages stacked on top of each other, reinforcing one another, compounding year over year. And there's a piece of this puzzle that almost nobody outside the industry thinks about. Actuators. The small, precise motors that let a robot's joints move like a human's. China already controls roughly a quarter of the entire global actuator market, about 26%, compared to something like 5% for the United States. Why does that matter so much? Because humanoid robots need dozens of these precision components per unit. And if you already dominate the supply chain for the parts, you have a structural head start before you even build your first robot. Then there's the raw materials problem, and this is where things get genuinely tense on a geopolitical level. Humanoid robots depend heavily on rare earth elements, the materials used in the powerful magnets that drive robotic motors, especially in the arms, where fine control and heat resistance really matter. China is responsible for something like 60% of global rare earth production. And earlier, when trade tensions escalated between Washington and Beijing, China tightened export controls specifically on rare earth magnets. Tesla actually got caught in the middle of this. Elon Musk himself acknowledged that Tesla was waiting on an export license just to get the rare earth magnets it needed for Optimus's arm motors, and that license could take 6 months or more to clear. Musk was blunt about it. Production only moves as fast as the slowest, least lucky component in the entire supply chain. And in this case, that component sits inside a country that is also Tesla's biggest robotic competitor. Think about the strategic weight of that for a second. The same country racing ahead of Tesla in humanoid robot production also controls a critical ingredient Tesla needs just to build its own robot. That is not a coincidence. That is leverage. Now let's talk about Tesla specifically, because Tesla is the name everyone brings up when this topic comes up, and for good reason. Elon Musk has bet an enormous part of Tesla's future, and a huge chunk of its trillion-dollar valuation, on Optimus becoming not just a product, but the product. Musk has thrown out numbers that sound almost like science fiction, humanoid robots, eventually outnumbering humans on Earth, production scaling into the millions, even up to 1 billion units in use by 2040. Some Wall Street voices, like famed investor Cathie Wood, have projected the humanoid robot market could be worth $26 trillion. Big numbers, big dreams. But dreams and delivery schedules are very different things. In early 2026, Tesla unveiled what it calls the Gen 3 Optimus, the first version of the robot actually designed for mass production rather than just flashy demonstrations. More than 1,000 of these Gen 3 units have been deployed, but here's the key detail. They're mostly inside Tesla's own factories in places like Gigafactory Texas and the Fremont plant. They're doing structured tasks on Tesla's own production lines. That's useful, that's real-world testing. But it is worlds apart from selling robots commercially to outside customers, which Chinese firms are already doing at scale. Musk has said publicly that Optimus won't be available for public purchase until at least 2027. Meanwhile, over in China, several manufacturers are already ramping toward mass commercial production in 2026. One Chinese company, UBTech, is targeting 5,000 units of humanoid robot production this year alone, climbing to 10,000 units the year after. That's not a projection about someday. That's a production plan with a calendar attached to it, already underway. There was also an uncomfortable moment for Tesla that's worth mentioning honestly, because credibility matters in this conversation. At one point, Tesla showed off an Optimus robot folding and ironing a shirt, a demonstration meant to showcase autonomous dexterity. It later came out that the robot was actually being controlled remotely by a human operator through teleoperation, not operating autonomously at all. That doesn't mean Tesla's technology is fake or worthless. Teleoperation is a legitimate and commonly used step in robotics development, but it does mean some of the flashiest visuals coming out of Tesla's robotics program have needed a closer, more skeptical look before anyone declares Optimus ready for the real world. So does that mean China has simply won? Full stop? No further discussion needed? Not quite. And this next part matters, because it's the difference between an honest analysis and empty fear-mongering. Several industry analysts have pushed back on the idea that Chinese hardware dominance automatically means Chinese victory in the broader humanoid robot race. Their argument goes something like this. Producing robots at scale is one kind of advantage, but building robots that can genuinely think, adapt, and operate autonomously in messy, unpredictable real-world environments, that's a different challenge entirely, and it's one where the West, and Tesla specifically, may still hold real advantages. Here's the distinction that matters. A lot of what's dazzled audiences from Chinese humanoid robots, synchronized dancing routines, backflips, martial arts choreography, even a robot that reportedly could have run a marathon in under an hour and 42 minutes, these are jaw-dropping displays of mechanical control and balance. But they are also, in large part, pre-programmed or specifically trained movements, choreographed and rehearsed like a routine. That is genuinely impressive engineering. It's real progress in balance, actuator control, and hardware reliability. But it is a very different thing from a robot walking into an unfamiliar kitchen it's never seen before and successfully, autonomously loading a dishwasher without being told exactly how. That second capability, general, flexible, autonomous intelligence operating in unstructured environments, is where Tesla is making its actual bet, and it's tied directly to Tesla's self-driving technology. Optimus runs on the same underlying neural network architecture that powers Tesla's full self-driving system, currently on its 15th version. It's a vision-only approach, meaning, the robot relies on cameras and neural networks to build an understanding of the world around it, rather than depending on LiDAR or heavily pre-mapped environments. The theory Tesla is banking on is this. Just as Tesla's cars learn to navigate roads by processing millions of miles of real-world driving footage, Optimus can learn physical tasks by leveraging Tesla's enormous computing infrastructure, its Dojo supercomputing clusters and vast banks of NVIDIA hardware, to simulate physical tasks millions of times over inside a virtual environment, using physics models grounded in real data collected from actual Tesla vehicles on actual roads. If that bet pays off, Tesla wouldn't need to win on raw manufacturing volume in the short term. It would win by producing a robot that's dramatically more capable of handling the unpredictable mess of real human environments, homes, hospitals, retail stores, places where nothing is scripted and everything changes moment to moment. Software and general intelligence, not just hardware and unit counts, would become the deciding factor. It's a real strategy. It's not just spin. But it is undeniably a bet, an unproven one, running against a competitor that is already generating real revenue and real deployment data from tens of thousands of robots already out in the field. And China isn't ignoring the software side either, which is the part a lot of people underestimate. There's a common assumption that China wins on hardware and America wins on AI. That gap is closing fast. Chinese companies are aggressively building out open-source robotics AI. Alibaba, for instance, has released an open-source robotics foundation model designed specifically to help robots understand and navigate three-dimensional space. Open-source development like this means the entire Chinese robotics ecosystem, dozens of companies, not just one, can build on shared advances simultaneously, accelerating progress across the whole industry all at once, rather than each company reinventing the wheel alone. If China manages to commoditize the brain of a humanoid robot as effectively as it has commoditized the body, the advantage Tesla is counting on could shrink dramatically and shrink fast. So where does Tesla go from here? Interestingly, part of Tesla's answer might involve leaning directly into the very ecosystem that's currently outpacing it. Reports indicate Tesla's China president has floated using the company's Shanghai Gigafactory, the same plant responsible for roughly half of Tesla's global car production, as a manufacturing base for Optimus itself. He's reportedly described it as a golden key for scaling up humanoid robot production. The logic is straightforward, if a little ironic. If China's supply chains for actuators, sensors, batteries, and precision motors are already the most advanced and cost-efficient in the world, then building Optimus inside that ecosystem could let Tesla capture some of the same cost advantages that have made its Shanghai-built cars among the most profitable vehicles in its entire lineup. In other words, instead of trying to out-manufacture China from the outside, Tesla may end up trying to manufacture alongside China from the inside, competing for supremacy of the exact market its rivals already dominate, using their backyard to do it. Now, zoom out for a second, because the story here goes beyond just Tesla versus a handful of Chinese startups. This is about where economic and technological power sits for the next several decades. Market forecasts vary wildly depending on who you ask, but they all point in the same general direction: enormous growth and enormous stakes. One major financial firm, RBC Capital Markets, estimates the global humanoid robot market could be worth up to $9 trillion by the year 2050, with China capturing more than 60% of that value. Other estimates, admittedly more. Optimistic ones tied to Tesla's own bullish narrative, put the eventual market as high as $26 trillion. Whichever number ends up closer to reality, we are talking about one of the largest new industrial markets in human history. And right now, China holds a commanding early lead in claiming it. There are real reasons to think China could hold onto that lead, and real reasons to think it might not. On the China keeps winning side, the country has an already vertically integrated manufacturing base concentrated in regions like the Yangtze River Delta, where humanoid robot makers sit close to the exact suppliers who build their components. Electric vehicle actuators and gearing systems, originally designed for cars, are already being repurposed directly into humanoid robot production, giving Chinese manufacturers a manufacturing head start most competitors simply don't have. There's also a demand-side advantage that's easy to overlook. Chinese state-owned enterprises are actively adopting these robots domestically, creating built-in demand at a scale that doesn't really exist yet in Western markets. That combination of supply chain depth plus guaranteed early demand is an incredibly hard thing to compete against. On the other side of the ledger, there are real weaknesses in China's position too. Despite the manufacturing dominance, the country's humanoid robots are still heavily dependent on chips manufactured outside China, particularly advanced AI processors. Their AI capabilities in unpredictable, unstructured environments still lag behind the most advanced Western systems. Production costs, even with all these advantages, remain high for the most sophisticated models. And Chinese regulators themselves have started publicly warning about the risk of an investment bubble forming in the sector. Too much capital chasing too much hype before the actual use cases and profits catch up to the valuations. That warning is worth sitting with for a second because it cuts both ways. It's not just a warning about Chinese robotics stocks, it's a warning that applies just as easily to Tesla, whose stock price has become deeply tied to Musk's promises about a robotic future that, so far, remains mostly promises. One industry commentator put it sharply: many people assume humanoid robots will soon surpass humans in flexibility, speed, and autonomy, but that gap between public perception and current reality is exactly what creates the conditions for an investment bubble. Whether you're looking at Shenzhen or Silicon Valley, the warning is the same. Hype moves faster than hardware. And hardware, as 14,500 Chinese robots against Tesla's 150 prove, is still the thing that actually matters when it comes to who is really leading. So, back to the question we started with. Has Tesla already lost the humanoid robot race? The honest answer is not yet, but it is not currently winning either, and the gap in real-world deployment is not small. China has translated years of deliberate state strategy, deep manufacturing infrastructure, and control over critical raw materials into an overwhelming lead in actual robot production and sales. Tesla and the rest of the American robotics industry are still largely in the demonstration and early deployment phase, betting heavily that superior software and general-purpose intelligence will eventually outweigh China's massive head start in volume. Whether that bet pays off depends on questions nobody can fully answer yet. Can Tesla's vision-based AI actually generalize to the messy unpredictability of real homes and real workplaces the way its self-driving software has tried to generalize to real roads? Can Chinese firms close the software and autonomy gap as fast as they've already closed the manufacturing gap? And will Western governments respond with their own version of a coordinated industrial strategy, the way China responded to the electric vehicle race a decade ago? Or will this play out exactly like EVs did? Years of underestimating the competition, followed by a scramble to catch up once the lead becomes nearly impossible to close? Let's talk for a moment about the rest of the field too, because this isn't purely a two-way fight between China and Tesla. It just looks that way because those are the two names that dominate headlines. In reality, there's a growing cast of competitors on both sides, and understanding them tells you a lot about where this industry is actually headed. On the American side, Tesla isn't even the most highly valued player. Figure AI, a company most casual observers have barely heard of, has seen its valuation rocket from around $2.6 billion to an eye-watering $39 billion in a very short span of time, despite shipping roughly the same number of units as Tesla. That tells you something important. Investors aren't necessarily betting on who ships the most robots today. They're betting on who they think will own the software and the platform tomorrow. Agility Robotics rounds out the American trio, focused heavily on logistics and warehouse applications rather than general-purpose humanoids, carving out a narrower but potentially more immediately profitable niche. On the Chinese side, it's not just Unitree and Agibot either. Fourier Intelligence and UB Tech are both major players targeting factory and logistics deployment, and UB Tech in particular is publicly traded on the Hong Kong Stock Exchange, giving outside investors a direct way to bet on China's robotics boom. Electric vehicle maker Xpeng has also entered the space, which underlines just how directly China's EV manufacturing expertise is bleeding straight into humanoid robotics. The same factories, the same supply chains, the same engineering talent, simply redirected toward a new kind of machine. And then there's Honor, a smartphone maker spun out of Huawei, whose humanoid robot reportedly won a half marathon in Beijing, finishing at a pace that would translate to roughly a 1 hour, 41-minute marathon. 21 new humanoid robot models were introduced in China in 2025 alone, up from just 3 models back in 2022, a 7-fold increase in a single year, and one of the clearest signals yet of how fast this ecosystem is scaling. Even Europe is trying to get in the game, though it's starting from much further behind. Germany's Robotics has emerged as one of the continent's most talked about humanoid robotics ventures, but by every available metric, funding, unit production, deployment scale, European humanoid robotics remains a distant third behind the US and China, watching this two-country race unfold from the sidelines while trying to carve out its own path forward. It's also worth understanding exactly where the innovation is physically clustering, because geography turns out to matter enormously in this industry. Just like Silicon Valley became the undisputed capital of software innovation because of its universities, venture capital density, and entrepreneurial culture, China has built its own version of that ecosystem for hardware and robotics. Shenzhen, working together with Hong Kong and Guangzhou, has emerged as the world's single leading innovation cluster for this kind of manufacturing-heavy technology. Beijing and the Shanghai-Suzhou corridor aren't far behind. These clusters combine research, institutions, component suppliers, assembly capacity, and capital all within a tight geographic radius, meaning a robotics startup in that region can go from a working prototype to small batch commercial production in a matter of months, not years. That kind of speed is extraordinarily difficult for any single Western company, however well funded, to replicate purely through internal effort. There's also a political dimension building quietly in the background that's worth watching closely. U.S. lawmakers have already begun raising concerns about China's humanoid robotics lead, and there are reports the U.S. government is preparing its own policy response, possibly including an executive order sometime in 2026 aimed at accelerating America's domestic robotics industry. Whether that translates into the D of sustained, well-funded, multi-year industrial strategy that China has already been running since 2021 remains to be seen. Policy announcements are easy. Building an entire manufacturing ecosystem to rival what China has spent half a decade constructing is a completely different challenge, and one measured in years, not headlines. So what should you actually take away from all of this, beyond just the raw shock of the numbers? Probably this. The humanoid robot story isn't a single race with one finish line. It's actually two separate races happening in parallel. A manufacturing race, which China is currently winning by an overwhelming margin, and an intelligence race centered on whether these machines can operate autonomously and reliably in the messy real world, which remains genuinely unresolved. Whoever ultimately wins that second race, if anyone truly does soon, will have an enormous say in how this multi-trillion-dollar industry gets divided up in the decades ahead. And right now, both China and the United States have very real, very different reasons to believe they can be the one to pull it off. One thing, though, is no longer up for debate. The idea that America, and Tesla specifically, automatically leads the world in robotics simply because Silicon Valley builds the flashiest keynote presentations, that idea is already outdated. The robots doing the real work right now, on real factory floors, being sold to real customers around the world, overwhelmingly come from one country. And unless something changes, and changes fast, the next decade of humanoid robotics may end up looking a whole lot like the last decade of electric vehicles, a story where the West saw the competition coming and still couldn't catch up in time.